In the human brain, there are actually several different types of memory. And the most common ones we think about are short-term and long-term. Personally, I actually have trouble with the short-term. I can go to a store and have 6 items to get and forget the last 2 and only come home with 4. And sometimes I can forget what I'm saying in the middle of a sentence. Wait a minute, what was I saying? Just kidding. On the other hand, I can remember movie lines from films I've seen years ago, can actually quote them verbatim. Suffice it to say, my long-term memory is far better than my short-term memory. In computing, short-term memory is the job of RAM, which we've already discussed. But for long-term storage, we look at disks, hard disks, solid-state disks, optical disks, and so forth. And so we actually want to take a look at what goes on inside this long-term storage in computers.
To begin with, it's important for you to have a good grasp of how storage operates, just some basic fundamentals when it comes to data storage in personal computer systems. Now, generally speaking, there are many ways to classify storage with regards to computing technologies. One way to understand storage is by contrasting the types you'll encounter. First, you have memory. Memory is RAM used by the PC for various calculations, program execution, and ultimately temporary storage. Now, as we learned in the lesson on memory, the contents of RAM are lost when the device is powered off. This is why it's sometimes referred to as short-term memory. Storage, on the other hand, are longer-term storage of various data. And there's various types of storage. First is hard disk, sometimes called HDD, that's the abbreviation. You have optical storage. And the various types of optical drives include CD drives, DVD drives, and Blu-ray drives. There are a number of subtypes that we'll actually deal with later. You have removable storage. This is things such as flash drives and others. You have external, which we'll be talking about in a separate lesson. And these are just some types of storage, just generically speaking, that you're going to run into. Another thing that's important to understand in terms of storage is you're going to hear various units of capacity or measurement when it comes to storage, especially with hard disk drives. So it's important for you to have at least a basic grasp of how these particular measurement classifications work. First, you have a byte, B-Y-T-E, and it uses the letter capital B. And this consists of 8 bits. Bits has to do with whether a particular circuit is on or off, but there are 8 bits in a byte. Then you have kilobytes, which may just naturally sound like 1,000 bytes, but it's actually 1,024, and there's a consistent mechanism in this regard. And you'll see KB in caps for this particular designation. Kilobits, by example, would be small or lowercase k and small or lowercase b. Then you have megabytes, which you'll frequently hear referred to. And this is 1,024 kilobytes. You'll notice there's hierarchy here. Then you have a gigabyte, capital G, capital B, which is 1,024 megabytes. Then you have a terabyte, capital T, capital B, 1,024 gigabytes, and you get into petabytes and so forth and so on. But these give you just a good representation of the different terminology that you're going to see with regard to storage capacity. Now, the most common type of long-term storage you're going to deal with is some form of disk storage. So I want to talk about that right now.
One of the things you need to be aware of as a technician is the existence of floppy disk drives. Now, granted, by modern standards, they're considered obsolete, but when the PC was first introduced, they were a vital part of information storage and retrieval. You may not run into it in production environments very much anymore, but you may come into situations as a technician where you actually need to load drivers or something else from a device like a floppy drive. These can be mounted internally on the system, or they can actually be connected externally through USB. In any case, let's just take a look at how this little device is put together. As you can see, this is a 3.5-inch floppy disk drive, and this is actually the front of the unit right here. There are a couple of things I want to make note of. First, you actually have the drive slot, which is located right here. You actually take the disk itself, you place it in front, push it in till it clicks, and that's when you know it's engaged. If you want to eject it, the ejection button is right here. You push it, and it will actually eject it back out. Another important item of note is the LED right here, which is a drive activity light. It will flash as data is being written or read. Never, ever eject it while this is flashing, or you could damage the media. And that's pretty much all there is to the front of the floppy drive. Now we'll turn it around. And here you actually have the other connectors that are pretty important. First, you have the power connector here, which is a mini Molex connector, which is still standard on all power supplies. This is what supplies electricity for the drive motor to run and so forth. And then you actually have your ribbon connector that goes in here. One end of the cable goes here, the other plugs directly into the motherboard. And that allows data to travel to and from the device. With USB, obviously, we just have a USB type of connector. And that's pretty much all there is to the floppy disk drive. It's a fairly simple device. Again, you may not run into it, but it's an important skill you need to have for the A+ hardware exam.
Floppy disks, which were heavily in use in earlier days with computing, but magnetic hard disks, again, HDD or hard disk drive, are the mainstay of most computers. We just want to take a brief look at the architecture of these devices. First, you have the actuator. This is actually the device inside the hard drive that actually causes movement in terms of the read-write heads. Then you have the spindle or motor. This actually turns the hard drive. If you have any experience with LP or 45 RPM records, which are very ancient by today's standards, it's the same idea. It's spinning at a certain speed in order to allow for data retrieval. Next, you have the actuator arm, which is actually moving across the disk in order to be able to read or write data. Then you have the read-write heads, which are actually at the very end of the actuator arm. They never actually touch the disk, but actually hover above it and actually read or write electrical pulses. In this case, magnetic pulses. And then, of course, you have the platters. And the platters are actually the disk surface itself, which has a number of different types of materials in order to be able to be magnetized in read and write operations. This is what the interior of a hard disk drive looks like. And this is what the external area of the hard disk typically will appear like. You have, of course, the printed circuit board. This is actually the controller. You'll sometimes hear IDE or integrated drive electronics. This is what this is referring to. You have your power connector, again, the Molex that we talked about during our power supply discussion. You have the data connector, this multiple pin cable, which is notched to allow correct orientation when putting it together. And then you have jumpers, which allow for various different types of settings with regard to the disk drive. Now we need to actually have a good understanding of how magnetic hard drives operate in terms of read and write. There's actually an entire system of hard drive encoding, and this uses data within analog magnetic fields, and each magnetic field or flux has two possible polarities, north or south. It's basic magnetism. And switching the polarity, as you could actually see here going one direction or the other, is called flux reversal. And this flux reversal creates electrical current, which will then represent a binary digit 1 or a binary digit 0. So you have your top and your bottom of the platter, which we looked at before. You have your read and write heads, the electrical current that we talked about, and then the flux reversals. And there are a variety of different types of encoding mechanisms, some of which are not even talked about anymore. There was RLL, or run length limited. There was partial response maximum likelihood, PRML. But essentially what these different types were used is to be able to figure out what constituted a 1 or 0 and how many of these pulses you could actually put on a particular magnetic disk. You can see the 1s and 0s represented by the various different types of pulses. Now, hard disks have a geometry to them. Typically, you'll have one or more platters within a hard disk drive, and each platter will have two heads, a top head and a bottom head. Platters themselves are divided into a number of different units. You have tracks. Within that, you have sectors, portion of a track. And then you have cylinders, and then sectors within each. So you'll see tracks, sectors, cylinders all used in various reference material regarding how hard disk drives are put together. Now, cylinder uses the same track number but spans all tracks across the particular surface of the disk. So it essentially is, as you see here, is actually logically on all of these different things. And the actuator will actually move across to be able to read these different sectors and so forth. And the best way to describe the geometry of a hard drive is cylinders, heads, and sectors per track. So as with any technology, there are both positives and negatives for using that particular technology. So let's just talk a little bit about magnetic hard disks, again, as opposed to floppy disk drives, such as FDD versus HDD, a little bit of the pros and cons of these magnetic hard disks. So magnetic hard disks typically have very high capacity. You can get amazing amounts of data on them. They tend to be typically low in cost when you think about cost per megabyte or cost per byte, however you calculate it out. And there are multiple form factors that are available. Obviously some for laptop drives, some for desktop drives, and so forth. But for every advantage, there is a corresponding disadvantage or drawback. To begin with, because hard drives are magnetic in nature, they are susceptible to EMI, electromagnetic interference, and that can be a point of contention or problem. They are also, because they are mechanical in nature, they are susceptible to damage or failure. You can have head crashes, you can have a degradation of the magnetic media, and there can be ultimately failure. And then you have slower performance. The other thing that I forgot to mention under damage and failure is if you physically drop the hard drive, you can actually crash that particular drive. Whether it's running or not, it can damage it. And typically, with regard to other types of media, you can get slower performance as well. Now, magnetic hard disks are not the only type of long-term storage available. In fact, over time, solid-state drives, or SSDs, have actually begun to emerge as much more viable. And essentially what SSD drives or solid-state drives do is they use memory chips to store data. There are no moving parts. And these are available in laptop and desktop form factors. It's a lot like flash drives, but much, much larger. And there's a variety of different form factors. You have 1.8 inches, 2.5 inches, 3.5 inches. And ultimately, these end up being much more expensive than their magnetic counterparts. Vastly superior performance, but much more expensive and typically smaller, as you can just see with the different sizes that are listed here. It's also important to understand how these particular devices attach to the motherboard and ultimately the personal computer. There are a couple different methods. One is called the ATA interface, which has been around for a long time. This is sometimes now called the parallel ATA or PATA or PATA connectors. And there are a number of different types. You have ATA1, which is also called just IDE or Integrated Drive Electronics. And you also have enhanced IDE, which is version 2 of the ATA, and this uses a 40-pin cable for data connection. And ATA controllers typically use a master-slave type of relationship. So you have the motherboard connection, you have the IDE or enhanced IDE interface. You can see that one is connected. And in order to be able to connect another, you have this sort of master-slave type of relationship. This is just a type of daisy chaining of the various connections that you can use in parallel ATA or PATA. You have one connected as a master, another as a slave, and there are various ways to daisy chain these. You have various types of jumpers that you can use to be able to set whatever in particular you're looking at. However, another more recent type of connector, which is far more efficient, is called SATA or serial ATA interface, as you see pictured here. This is a direct connection between the device and the motherboard. It uses smaller cables. There's a 40-inch maximum cable length. It's a much cleaner connection, and you don't have to do this master-slave type of arrangement. And there's no maximum number of devices. In fact, the only thing that's a maximum on this is simply the amount of ports that you can actually connect to physically on the motherboard. And it is backward compatible with PATA. Obviously, much, much faster throughput. For instance, in ATA, you typically have 133 megabits per second, and in SATA, you have 150 to 300 megabits per second. Much, much faster. You can see the connector on the motherboard and then the connector on the back of the hard drive pictured here. Now, in addition to magnetic media, floppy disk drives, hard disk drives, and solid-state media, SSD drives, you also have various types of optical drives. These have evolved substantially throughout the years, and you need to have a good working awareness of how these operate and what they do. First, just understanding the general principle of optical drive operation. The same basic principles are used with different media, obviously with different capacities and so forth. But essentially, you end up with media that has some sort of a polycarbonate layer, a lacquer layer, an aluminum layer, which is essentially at the core, and a laser is used to read and write data to that particular disk. And essentially, the laser burns these pits into the media itself, so that then this can designate the 1 or the 0, which is essentially the storage of data. As a result, you end up with a series of zeros and ones for data storage. This allows you to be able to create a usable piece of long-term storage that isn't magnetic. So you have the different pits that are created and then the patterns that are used when the laser is reading back those bits of data. And there's all sorts of uses for this. You can use these types of media for software distribution and installation, music and video reproduction, data transfer, data backup and archiving, And there are a variety of different interfaces, just as there were with magnetic type drives. You have PATA, you have SATA for your internal connections, and for external connections you have USB, FireWire, eSATA, and so forth. And there are different types of media that you need to be familiar with. The first is the compact disc or CD-ROM. And the general capacity of a CD-ROM is 650 megabytes. Data is contained on one side of the disk, and the standard speed is referred to as 150 kbps, which is considered 1x speed. And there's various lasers that you could use as well. So there's that CD-ROM, which is one of the standards. Then you have CD-R, which is a recordable CD. A CD-ROM is not one that you can actually create yourself, but you can read from a CD-ROM drive. A CD-R actually allows you to be able to, one time, create the media using the laser, creating the pits as we talked about before. It's still only done on one side of the disk, but data can only be written once in one session. And CDRs typically records up to 8x speeds and reads up to 24x speed. Then you have CD-RW. This allows you not just to be able to write the data once, but actually be able to read and write multiple times. Obviously, there's a physical limit to how many times you can read and write, but you can do it more than one time, more than one session, and use it that way. There are 3 CD-RW speeds. There's the CDR record speed. Then there's the CD-RW rewrite speed, and you could get up to 16x speed for CDR type media, for up to 8x speed for CD-RW, and reads up to 48x speed. So compact discs, by far one of the least expensive storage methods per megabyte. Then you have DVDs, which there's been a variety of different references to this. Sometimes it's called digital video disc. The designation, as I remember when it first came out, it actually stood for digital versatile disc. They tend to be used interchangeably now. But it improved the capacity over compact discs. You had single-sided and double-sided, which meant that you could actually just read or write to one side or to multiple sides. Then you had single layer and double layer, where you actually had more than one layer that you could read and write to. And again, there's a variety of different standards related to this. You had DVD-ROM, which supported 4:3 and 16:9 aspect ratios, used the MPEG-2 standards, and could actually support DVD-ROM and CD-ROM simultaneously. Then you had DVD-R, -R, and +R, and this just had to do with different standards. The DVD-RW Alliance had the +R and the +RW, and the DVD Forum had the DV -R and -RW. It's just different ways of being able to record the same type of data. Next you have Blu-ray disc, which has become very much the standard for high-definition video in home entertainment, and obviously has corresponding use in personal computing as well. The standard disc is used with computers and movie players. There's a single layer that supports 25 gigabytes and a double layer that supports 50 gigabytes. Then you have various standards. You have the BD-ROM, the BD-R, and BD-RE, and then there's even a mini disc as well.
So as we have been discussing internal storage system, that typically equates to disk-based systems, such as CDs and DVDs for optical drives and hard disk drives for magnetic drives. We want to take a moment now to actually install these types of devices in our system project so you can get a better feel for how that works. First, we're going to install, in this case it's a DVD drive. Actually says it on the front, so that makes it easy. But I wanted to flip it around to actually show the cabling here. This is actually an IDE or ATA cable. We're actually going to use it to put this in the system and connect it to the motherboard. You'll notice that there's also another connector here, and this will actually be what the hard drive attaches to. One thing we can do to make sure that this stays where it's supposed to is actually put in this case we'll just put in one screw just to hold it still, because otherwise it can slide right back out the way it came in, or it can keep going within the system. So you want to make sure it's flush in the front, and you just simply tighten the screw. Simple enough, don't you think? Now here is the back of the connector. And it actually goes in this somewhat secluded spot on the motherboard here, which is an ATA type of connector. And you simply line up with the notch that's here. and it slides and pops right into the motherboard like that. Now, to add a hard disk drive, which is what's pictured here, same type of connector, we would simply be able to slide it into the system here. It can be a little bit of tight fitting sometimes. Always be gentle with the components. Then we can actually take this connector, put it on the back to complete the installation process. And if we wanted to, we could actually put another screw in here. Let's do that now. It's not all the way forward, but you see the point. And that's really the sum total of what it takes to be able to connect these, along with power, Molex type connectors, which connect there and connect up here to the DVD drive. So power, data, and motherboard connection. And that, my friends, is internal storage systems.
So just as we wrap up, let's look at just some terms to remember. Internal storage, this is a storage device that is installed within a computer system, meaning internally, such as the drive bays and so forth. A cylinder is a group of corresponding tracks that appear on both sides of every platter within a hard drive. If you remember our diagram, we had to show 3 platters. You had tracks on each one, and the cylinder was the summary of all those tracks on each platter all the way through. Then you had magnetic hard disk drives, sometimes just referred to as HDD, which is in contrast to floppy disk drive or FDD. This is an internal computer storage device that uses encoding schemes on magnetized disks to store information, typically just called a hard disk drive. Then you have a solid state drive or SSD. This is a type of computer storage device that stores data on electronic components rather than on traditional magnetic disks.
Maybe one of the nicknames for this lesson could be everything you wanted to know about disks and were afraid to ask. You have to admit it's pretty comprehensive. There's a lot of deep detail, and there's even more detail if you want to read on it. But the point to remember is this is the long-term memory of the system. When the system is turned off, this is where things are stored, programs, data, and so forth. Hopefully now you'll be able to remember what we talked about in this lesson, and we'll talk more soon.